In this session, we will learn how to create the geometry of a CFL bulb from scratch. Maybe you or a family member have even installed a CFL bulb in your house. These bulbs are more energy efficient compared to incandescent bulbs. CFL stands for Compact Fluorescent Lamp. There are different types of CFL bulbs available on the market. For this exercise, we will be modeling the bulb with a helical shaped tube and a screw base. So, how can we build this CFL model? Let's first analyze the technical drawing and plan how to build the model. In the technical drawing, we can see different views. Looking at these views, we can broadly divide the CFL bulb into three sections. The first one is the central section, which is called the ballast. Then the helical shaped tube. The last section is the screw base. We can first sketch the central section using the dimensions provided in the front view. Once the central section is done, we can create the helical tube. It can be seen that a couple of helix details are provided in the technical drawing. Also, notice that there are two helical tubes. We will create one tube and then create a copy and rotate it by 180 degrees. The last step in the helical tube creation will be to connect the two tubes at the top using dimensions specified in the front view. Finally, we need to create the screw base. The details of the screw thread can be found here in the technical drawing. Looks like we have a plan. First, create the central section, then the helical tubes, and finally the screw base. So let's get started. Open a new SpaceClaim session. Go to the File menu and click SpaceClaim Options. In the Units section, make sure that the unit type is set as metric and length as millimeters. Click OK to close the panel. Select the Z-axis from the Orientation tool. Then right-click and select New Sketch Plane. Click to define the sketch plane along the XY plane. As per the plan, we will first be creating the central section. From the technical drawing, we can see that the central section is cylindrical with a diameter of 50 millimeters and a height of 20 millimeters. From the Sketch tab, start the Circle tool and create a circle of diameter 50 millimeters at the center of the grid. Switch to 3D mode from the Design tab. The Pull tool is already activated. Rotate the face slightly and then pull it down in the negative Z direction by 20 millimeters. Select the bottom face and click Sketch Mode. Select the Move Grid option located at the bottom of the window and move the grid down by 23 millimeters. Press V to orient the sketch grid to the plan view. Create a circle of diameter 26 millimeters at the center of the grid. Return to 3D mode and click the Blend tool. Select the bottom face of the cylinder and the circular face. We can see a preview of the blend section that will be created. The preview looks okay, so let's complete the operation. We have now completed the central section. That was pretty fast, wasn't it? Let's move on to create the helical tubes. In the technical drawing, we can see two helical tubes, and, as planned earlier, we will create one tube, then copy and rotate it. From the front view, we can see that the tube diameter is 10 millimeters, and its starting section is straight and has a length of 5 millimeters. Also, it's located 15 millimeters away from the center line. So let's create it. Select the top face of the cylinder and switch to sketch mode. Orient the view to the plan view. Click the Circle tool. Place the cursor at the center of the grid and press the Shift key to activate reference dimensions. Specify a dimension of 15 millimeters along the positive x-axis and press Enter. This will define the center point of the circle. Create a circle of diameter 10 millimeters. Switch to 3D mode. With the Pull tool already active, pull the circular face upward by 5 millimeters. Let's go back to the technical drawing and analyze the helical tube. To create any helix, we need to know two basic parameters: pitch and height. Pitch is the distance between 2 points on the helix when it makes one full turn of 360 degrees about the center axis. Whereas height is the total distance between the start and end points of the helix measured along the center axis. From the sectional view, we can see that the pitch is 25 millimeters and the height is 50 millimeters. Also, if you notice, the helix dimensions are created on a section BB that is at an angle of 45 degrees from the ZX plane. Let's go on to create the helical tube. We will first create the plane. Press the Control key and select the X and Z axes and click the Plane tool to create a plane. Click the Move tool and move this plane around the vertical Z axis by 45 degrees. For creating the helical tube, there are a couple of approaches that can be used. You can first create a circle and revolve it to create the helical tube, or you can create a helical curve first and then convert it to a helical tube. For this exercise, we'll go with the helical curve option. We need to create the starting point of the helical curve. Select the plane and switch to sketch mode. Orient the grid to the plan view. Click the Point tool and using the Shift key, specify a horizontal distance of 25 millimeters from the vertical axis and a vertical distance of 20 millimeters from the top face of the central section. Switch to 3D mode and hide the plane. Select the Pull tool. Select the point. From the tool guides, click the Revolve option and select the Z-axis as the axis of rotation. From the Options panel, enable Revolve Helix. Enter the height as 50 millimeters and the pitch as 25 millimeters. Then hit Enter. This will create a helix. Press S to exit the operation. If we go back to the technical drawing and look at the top view, we can see the details of a second helix. This helix is basically connecting the helix that we just created and the top central tube. So let's create it. We need to first define an axis of rotation for this helix. Select the Z-axis and click the Axis tool to create a new axis. Click the Move tool. Then select the axis and move it along the X direction by 10 millimeters. Now, orient the view along the Z-axis. With the Move tool still active, move the axis along the Y direction by 10.5 millimeters. The axis location is now defined. Click the Pull tool and select the upper endpoint of the helix curve. Select the Revolve option and select the axis. From the Pull Options panel, enable the Revolve Helix option. Specify the height as 4.5 millimeters and the pitch as 12.5 millimeters. Then hit Enter. The helical curve is created and we now need to convert it to a cylindrical tube. Double-click any curve to select both the helical curves. Then click the Cylinder tool and specify a value of 5 millimeters and hit Enter. This will create a cylinder around the two helical curves. Let's connect the helical tube to the straight section of tube. Hide the axis. Select the Z and X axes, press Ctrl for multiple selection, and switch to sketch mode. Orient to the plan view. Click the Line tool and create a vertical line of 5 millimeter length at the center of the small cylinder. Switch to 3D mode and hide both the solid bodies. Click the Blend tool and select the lower endpoint of the helix curve and the upper endpoint of the vertical line. Click the Select Guides option and select the vertical curve. Then press the Control key and select the helix. The guide curves will help the new curve to maintain its tangency with both the curves. This can be seen from the preview. Complete the operation to create the curve. Now, display both the solid bodies. With the blend tool still active, first select the end circular face of the helix, and then the circular face of the vertical cylinder. Then click the Select Centerline option and select the curves that we just created. We can see the preview of the geometry that will be created. Complete the operation. The section of tube is created and all the bodies are also combined into a single body. Now that we have created one helical tube, let's copy it. First, click the Split Body tool. Select the body, then select the circular face as the cutter tool to split the body. The tube is now separated from the central section of the bulb. Triple click on the helical tube body to select it, then press Ctrl+C followed by Ctrl+V to create a copy of the selected body. With the body already selected, click the Move tool. Rotate the body about the Z-axis by 180 degrees. We now have the two helical tubes of the bulb. The last step remaining is connecting the tubes at the top. Hide all curves from the structure tree. Select the Z and X axes and switch to sketch mode. Click the Circle tool and create a circle of diameter 12 mm at a vertical distance of 74.5 mm from the center. Switch to 3D mode and select the Blend tool. Select one of the end faces of the helical tube, then the centrally located circular face, and then the end face of the other helical tube. Complete the operation to create the connecting section. The tubes of the CFL bulb are now created. It's good to save the project at this stage. Go to the File menu and click Save. Specify the file name as CFL bulb and save it in an appropriate folder. Now let's create the screw base. From the technical drawing, it can be seen that the base has a cylindrical section at the top, then the circular threads, followed by a tapered region at the bottom. The major diameter of the thread is 26 mm, and the minor diameter is 22 mm. We will create a cylinder at the mean diameter, which comes out to be 24 mm, and then create the threads around this cylinder. Also, if you closely look at the threads, you can see that they have been chopped off at the top and bottom, and then combined with the top and bottom sections. Let's design the screw base. Select the bottom circular face and switch to sketch mode. Orient to the plan view. Click the Circle tool and create a circle at the center with a diameter of 24 mm. Switch to 3D mode. Pull the inner circular face down by 27 mm. Click the Split Body tool and split the body using the small annular face. Hide the upper body. Select the Z and X axes again and switch to sketch mode. As noted earlier, the threads are chopped off from the top and bottom section. We will start by creating the threads from the top. For creating the threads, we will be using the approach of first creating the cross-section of the thread, and then revolving it to create the helical shape. Let's get started creating the cross-section. Zoom near the cylindrical body, and select the Sweep Arc tool. Place the center of the arc at a distance of -1 mm vertically downward from the upper right corner of the body. Then, click the upper corner point and sweep the arc in a counterclockwise direction to create a semicircle. Create another semicircle located at a distance of 3 millimeters downward from the upper right corner of the body, but this time from the outer side. Make sure that the two semicircles are touching each other. Next, click the Line tool and create a vertical line along the diameter of both the semicircles. Switch to 3D mode and hide the solid body to view the surface body. Now, display the base solid body again. With the Pull tool activated, select the surface body from the structure tree, then click Revolve. Select the cylinder face to define the axis of rotation. From the Pull Options panel, enable Revolve Helix. Specify the height as 20 millimeters and the pitch as 4 millimeters, and hit the Enter key. Did you notice that this single operation performed multiple operations? The outer section of the thread got merged with the cylinder, whereas the inner section removed the material and created the groove. I'd say that was an intelligent operation. Now that we have the threads created on the body, we need to split the top and bottom section. Select the top circular face and create a plane. Click the Move tool and move this plane down by 4 millimeters. Click the Split Body tool. First, select the solid body, and then click the plane to split the body using this plane. Once the body is split, click on the upper body to delete it. Now, select the bottom circular face and create a plane. Move this plane upward by 7 millimeters. Using Split Body, split the body using this plane and delete the lower body. Hide the two planes and display the upper body of the CFL bulb, which has the helical tubes. Select the bottom face, then click the Pull tool. Notice that if you pull the face, it will follow the shape of the upper curved face, which is not desirable. We need to create a cylindrical body. So, with the circular face selected, press the Control key and select its outer edge. This will break the continuity with the upper face and create a straight cylinder. Click the Up To option and select the top circular face of the threaded body. Notice that this operation also merges the two bodies. Now, hide the solid body. Display the bottom plane, and switch to sketch mode. Then, create a circle of diameter 26 millimeters at the center of the plane. Return to 3D mode, and pull the circular face down by 7 millimeters. Hide the plane. Using the Pull tool, select the upper circular edge. From the Pull tool options, select the Copy Edge option and pull the edge down by 3 millimeters. With the Pull tool still active, select the lower cylindrical face and change its radius to 8 millimeters. Again, select the same cylindrical face and click the Draft option from the Pull tool. Select the bottom face of the upper cylinder as the draft plane. Hit the spacebar and specify an angle of 45 degrees and press the Enter key. This creates the tapered section. Now, click the cylindrical face of the upper cylinder. Then click the Draft option and select the top face. Specify an angle of -45 degrees and hit Enter. This creates the second tapered section. Let's create fillets at the outer edges. With the Pull tool still active, select the 3 circular edges. Create a fillet of radius 1 millimeter. Now, display the upper solid body and using the Combine tool, combine the two bodies. Click the Pull tool and select the circular edge. Specify a radius of 0.25 mm and create a fillet. Similarly, select the upper circular edge and create a fillet of 0.25 mm. Lastly, select the two circular edges and create a fillet of 1 mm. This completes the creation of a CFL bulb. Let's clean up the structure tree before we save the model. Right-click and select the Show All option. Then, hide only the solid body representing the bulb. Press Ctrl-A to select all the visible entities, and then press the Delete key to delete them. Now, display the solid body. The structure tree should only contain the solid body. Lastly, go to the File menu and save the model. Congratulations! You've completed the design of the CFL bulb.